We shall continue with complex numbers in rectangular or Cartesian form. In this video, we will learn how to perform division of complex numbers in rectangular or Cartesian form. In order to obtain the quotient of two complex numbers, you need to multiply both the numerator as well as the denominator by the conjugate of the denominator. Now this sounds very complicating, but actually it's quite simple to do. Let's see. So I'm given two complex numbers, z1 and z2, and I'm interested to find z1 divided by z2, which means I want to find the quotient of these two complex numbers. Before I start, let me first write down the two complex numbers as given to me. Okay, according to the instruction above, I first need to find out what is the conjugate of the denominator. So where is the denominator exactly? The denominator is this here. And we know that to find a conjugate of a complex number, we will need to keep the real part unchanged, but change the sign of the imaginary part. So that means the conjugate of this complex number is x2 minus jy2. And we will take this conjugate and multiply it to both the numerator as well as the denominator of the quotient we are trying to find. Looks like I will need to perform complex number multiplication for both numerator and denominator. So I'll need to do distributive law of multiplication. Now let's start by multiplying out the numerator. So the first term x1 times x2 will give me x1 times x2 will be x1, x2, followed by x1 times minus j y2. So I get minus j x1 y2. Once that's done, let's take the second term now and multiply to this. So j y1 times x2 I get plus j x2 y1. And then multiply to minus j y2. So I get minus j times j is j square. y1 times y2 is just y1 y2. So the numerator is done. Let's now multiply out the denominator. Same thing for denominator. I'll take the first term and multiply to x2. x2 times x2 is just x2 square. Then x2 times this. So I get minus j x2 y2. When that's done, I will multiply this term to this term. So I have j y2 times x2, I get plus j x2 y2. And finally, this times this, which is minus j times j, j square, and y2 times y2 is y2 square. So both the numerator and denominator have been multiplied out. Now I shall try and simplify them. So right at the top in the numerator, I have x1, x2, no change to that. And then minus j x1, y2, no change to that either. I can't simplify it anymore. Plus j x2, y1, no change to it either. And then I come across this, minus j square y1, y2. Recall that j square is negative 1. So I'm going to replace this j square with minus negative 1 here. So the numerator is done. Let's now do the denominator. x2 square remains as x2 square. Minus j x2 y2 plus j x2 y2. These two cancel each other out. So I'm left with nothing from here. And then minus j square. Again, change j square to minus 1. So I have minus 1 y2 square. Okay, let's continue to simplify. Minus 1 is just plus 1, so I get this. At the bottom, x2 square. Minus 1 is plus 1, so I have plus y2 square. Now, since I'm expecting to see a complex number coming out of here, what I'm going to do now is to group the real parts together and group the imaginary parts together. So x1, x2 will group with y1, y2. So I have x1, x2 plus y1, y2. And then I'm going to divide it by the denominator, which is x2 squared plus y2 squared. Similarly, for the two imaginary parts, I'm going to group them together. So I'm going to write it as plus j bracket negative x1 y2 plus x2 y1. And that also divide by x2 squared plus y2 squared. So this is the answer for the quotient, division of complex numbers. This is the real part. This is the imaginary part. Now you realize now, after completing the division, the denominator has no imaginary part. There is no j in the denominator. So at this instance, I'm quite sure my division is complete. Now let's practice what we just learned. I'm given this complex number to divide by this complex number. So let me just copy down the question. Now recall from just now, to do division of two complex numbers, I will need to find the conjugate of the denominator first, and then take that conjugate and multiply it to both the numerator as well as the denominator. So the very first important thing I need to know is, what is the conjugate of minus 1 minus j? Yes, the conjugate of minus 1 minus j is minus 1 plus j. So I'm going to take that and multiply to both the top and the bottom. Why is it minus 1 plus j? Because we have kept the real part unchanged, but changed the sign of the imaginary part to the opposite sign. Okay, now we are ready to distribute out. So let's start to multiply the numerator, then we'll do the denominator. So let's go. 2 times negative 1, I have negative 2. 2 times plus j, I have plus j2. Continue. Plus j3 times negative 1, I have negative j3. Plus j3 times plus j, I have plus j squared 3. I'm done with the top. Let's do the bottom part now. Minus 1 times minus 1 is 1. Negative 1 times plus j is negative j. Next, negative j times negative 1 will be plus j. Negative j times plus j will give me negative j squared. Again, j squared is negative 1, so I'm going to simplify it. So I have minus 2 plus j2 minus j3 plus, change my j squared to negative 1. Again, change my j squared to negative 1. Now I'm ready to tidy them up. So I have minus 2 plus j2 minus j3 minus 3 over 1. And then I realize this part cancel each other out. So I get 1 minus minus is plus 1 plus 1 at the bottom. Realize my denominator no longer has an imaginary part. Now let's tidy up the numerator. The real part minus 2 minus 3 will give me minus 5. The imaginary part plus j2 minus j3 will give me plus j bracket 2 minus 3. The 2 comes from here, negative 3 comes from here. Let's continue. Minus 5 minus j over 2. And so I can split up the fraction and write it as minus 5 over 2 minus j half. And that is my final answer. How would you simplify this division of complex numbers? What's your answer? Firstly, let me copy down the question. Then I'm going to look for the conjugate of the denominator. The conjugate of 1 minus j is 1 plus j. So I take 1 plus j, put it at the top and the bottom, and then I multiply it to the original quotient. Then I'm ready to distribute. Let's do the numerator first. 1 times 1, 1 times j. Next, j times 1, and then j times j. Once we're done with the numerator, let's do the denominator. 1 times 1, 1 times j, negative j times 1, negative j times j. Recall that j square is negative 1, so I'll change all the j square to negative 1. Let's tidy up. 1 minus 1 will give me 0. J plus j gives me j2. That's at the top. At the bottom, 1 plus j minus j plus 1 will give me 2. The reason is j minus j cancel each other out. So my final answer is j. This is my final answer.